We're going to talk about section 1.6, and the main thing we're going to talk about is piecewise functions. We've talked already about how to evaluate piecewise functions. So, for example, on this example 3, which is in section 1.6, if I said what's f of 0, you'd have to go to which interval would require, would it be x equals 0. So x equals 0, 0 is less than or equal to 1, which means I would plug in 0 here. If I said what's f of 10, 10 is greater than 1, which means I'd plug in the 10 here. We're going to talk about how to graph this on Desmos. And so we've got this function. So again, example 3. So when you have Desmos, you're basically typing in like this. So for example, if I said f of x, the first part's 2x plus 3. So we know 2x plus 3 looks like this. We know that's just a linear function, slope of 2, y-intercept of 3. But in order to restrict its domain, according to this problem, we only care about the 2x plus 3 when x is less than or equal to 1. So what I have to do is I'm going to go down here. And remember with Desmos, you may need to scroll down just a little bit. And so I'm going to use this ABC here. And then what I'm going to do is I've got this little squiggly line. So I'm going to take that little squiggly line. And then I'm going to type in restricted according to what it says. This says less than or equal. So here, I'll type in x and then less than or equal to. You have less than or equal to right here if you want to do that. And then the squiggly looking line, such as that. Notice that restricts it now. So it stops right here. It's including when the x value is 1, which means at the very last point here, that is an actual point. The next thing it says is f of x equals negative x plus 4. So I'll go down to the next line. F of x equals negative x plus 4. I'm going to restrict that domain again. This time, x is greater than 1. And so it looks like that. So this would be what it would look like. So that's an example of a piecewise function. Next example is this number 39 in the actual exercises. So this has 3 different pieces. So I'm going to do the same thing here. So the first one, it doesn't matter if you call it y or h of x. I'll just use h of x because that's what the problem gives me. H of x equals 4 minus x squared. And so we know it looks like an upside down parabola. But I'm going to restrict the domain this time. So I can use my squiggly here. And this time it'll be x less than negative 2. So notice that just looks now just like kind of a side of a curve here because we restricted its domain. Go down here, h of x equals, we've got a new part. So this is saying it's 3 plus x. That's just a line. So 3 plus x is a line. Squiggly line, this says that this one's between negative 2 and 0. It's including negative 2 because it's less than or equal to x, and then not including 0. So negative 2, I can do less than or equal to x, and then less than, and then 0. So notice that it's just a line between here and here. So it's including at negative 2, but it's not including here at that. Notice that if you go all the way up and click on up there, it did say undefined. So it says 0, undefined because it can't have that value. It's not included. And then the last piece is x squared plus 1. X squared plus 1, and I restrict this domain so we know it looks like a U-shaped curve. Shift that up, and then this is going to be x is greater than or equal to. So x is greater than or equal to 0. And so that only kind of gives that piece. So you can see that there are 3 distinct pieces, and Desmos color coordinates it. So you can see, the red one looks like this side of that curve. This is that kind of in-between line, and then this is the right side of that curve.